Okay, let us discuss the problem that we were discussing in the previous class. At the end of the previous class, the problem said that you consider a manufacturing company that has 4 plants: one in Dammam, one in Riyadh, one in Makkah, and one in Qasim. Then it says 20% of the manufactured items are coming from Dammam, 30% they are manufactured in Riyadh, 10% in Makkah, and 40% in Qasim. That implies that your probability of B1, B2, B3, B4, if you represent B1, B2, B3, B4 by 4 different plants, then their probabilities, the given probabilities are 0.2, 0.3, 0.1, and 0.4 respectively. The thing where we all were discussing was this green part and how this green part is given in let me unhighlight this green from here and highlight it with a different color, because this green is not the green in the diagram. So we are discussing about this blue part where it is written that the further the rate or the probability of defective objects within the MOM. So this probability is given as 0.015, and we were debating, is this probability, which is 0.015, is it A intersection B1, which is the probability of having an item from the MOM and defective, or is it the probability of having a defective item given it is from the MOM? So this is what we were debating, what this 0.015 is. And I tried to explain this with reference to this statement. And in this statement, I wrote 2 different wordings. One of the wording was a randomly chosen product is made in the MOM and it is defective. This one is basically probability of A intersection B1. That you choose a random product and you don't know from which plant it is. And you're trying to find the probability that number 1, it is from the MOM and also it is defective. That's probability of A intersection B1. And the second wording that I'm using is that find the probability that a product manufactured in the MOM. Now I'm telling you that this product is manufactured in the MOM. Now you find the probability that it is defective. So this thing is going to be denoted by A given B1, of course. Now you look at these 2 statements and then you decide the given statement in the question is closer to the first one or closer to the second one. Again, read the 2 statements I just showed you on the screen. One of the statements says that a randomly chosen product, you don't know from which plant, find the probability of whether this is from the MOM and it is defective or not. So you're completely blind at the moment. You don't know it is from which plant and you don't know if it is defective or not defective. So in this case, you're trying to find A intersection B1. Both of the events are your interest. A is your interest, whether it is from the MOM defective or not. B1 is also your interest, and you're interested in and. There is event A made in the MOM. There is event, sorry, this is B1. There is event B1 and there is event A. And you're interested in both of them, B1 and A. On contrary, here your interest in the second statement, your interest is in defective. While you know the manufactured item is from the MOM. So now you look at the 2 statements and you decide what is this blue statement. The blue statement says the rate of defective or the probability of defective in the MOM is 0.015. So this, of course, is talking about specifically the mom. So we know a product from the mom, the probability of defective is 0.015. If we know that the product is from the mom, then the probability of defective is 0.015. If you know the product is from Riyadh, then the probability of defective is 10%. 10% or 1%. If you know the product is from Makkah, then the probability of defective is 0.6% and so on. So these given probabilities in the question, these are not the intersection probabilities. These are conditional probabilities. And yes, you are interested in intersection probabilities to get the total probability of A. And to get the intersection probability, you need to multiply them with the corresponding weights. This is the defect rate of the first plant. So the probability of defective and first plant is going to be this probability multiplied by the corresponding weight, which is 0.2. Plus the second probability multiplied by the corresponding weight. This is what we did at the end of the lecture. We said that the total probability of defective is the defect rate of the mom multiplied by the weight of the mom. The defect rate of Riyadh multiplied by the weight of Riyadh. The defect rate of Makkah multiplied by the weight of Makkah plus the defect rate of Qasim multiplied by the weight of Qasim. So overall defect rate of the company was found out to be 0.0086. To make the things even more easier for you, I'll give you an example which is more relevant to you. For example, you are taking a student X is taking 3 courses in a specific semester, 4 courses, let us say, in a specific semester. One of them is 3 credit, one is 2, one is 3, and one is 5 credit. And then you get a GPA. In 3 credit, you get a GPA of, let us say, you get 3. In this 2 credit, you get 3.75. That means you get A. In this another 3 credit course, you get 2.5. And in 5 credits course, you get 2.0. Raise your hand if you can tell me how do you find the CGPA of this semester? Yusuf.
We multiply the the GPA by the credit for everyone. Then we sum them and divide them by the sum of the credits.
By the sum of the credits, or indirectly. Let me tell you what you are saying. You're saying that you will multiply this 3, which is the GPA of first course, multiplied by the credits, plus 3.75 multiply the credits, plus 2.5 multiplied by the credits, plus 2 multiplied by the credit, divided by the total credit, which is, I think, 13. Right?
Yes.
Or I can also write this one as 3, which is the GPA of first course multiplied by 3/13, which is the weight of your first course, plus 3.75, which is the GPA of your second course multiplied by 2/13, which is the weight of your second course, plus 2.5 multiplied by 3/13, plus 2 multiplied by 5/13. Now look at this and look at this. This 2/10, 0.2 is basically the weight of the mom part. This is basically, you can also write it as 2/10. And 0.015 is basically the GPA of the mom. 0.3 is the weight of Riyadh. 0.01 is the GPA of Riyadh. 0.1 is the weight of Makkah. 0.006 is the GPA of Makkah. So to find the CGPA, to find the overall defect rate, to find the overall GPA, what you do is you multiply the GPA of each credit with the weight of each course with the weight of that course. So in CGPA calculation, you are exactly implementing the theorem of total probability. With the same spirit. Okay, any question until I move forward now with the last part?
So, Doctor, if we need to calculate like all the manufacturing, if it is effective or defective, we need like do like GPA.
Exactly like GPA. You need to do the calculations exactly like GPA.
Okay, thank you.
Okay, another question. If I pick an object randomly, a manufactured object randomly, what is the probability that it will not be defective? Who can tell me? Raise your hands. Muhammad Faris.
Not defective, right?
Not defective.
1 minus probability of A.
1 minus probability of A, simply. Or if you want to use the theorem of total probability, you can use it here, like 0.2 multiplied by the not defective rate of the MUM, which is 1 minus 0.015, plus 0.3 multiplied by 0.99, plus 0.1 multiplied by the non-defective rate of Makkah, and so on. That will also give you exactly the same answer, 1 minus probability of A. This question can be solved in two ways. Either first you find the probability of defective and then take the complement. You can get 1 minus 0.0086. Or you can find this probability directly from the theorem of total probability, that is probability of B1 multiplied by probability of A complement given B1. Probability of B2 multiplied by probability of A complement given B2, plus the third plus the fourth. And this will be 0.2 multiplied by this probability of being not defective from the MUM is 1 minus 0.015. Plus 0.3 multiplied by 0.99, which is 1 minus 0.01. Plus 0.1 multiplied by 1 minus 0.006. Plus 0.4 multiplied by 1 minus 0.005. This will also give you the same answer. Let me calculate it exactly and I'll tell you what is the exact answer. What is 1 minus 0.0086?
0.9914.
0.9914. You will get 0.9914 from both solutions. any way you like. Okay, let us move on to the next question. In the next question, it says that if an object is selected randomly and found to be defective. Now, look at the question. And found to be defective. That's the given information. The first thing you have to look into the question, what is given and what is required. It is given that you selected an object and it is defective. So that will come after the given sign, after the flat slash. What is the probability that it was produced by the plant located in Riyadh? This is required. This is required. So you always write the question like probability of required / given. So who can tell me what is required in this question? Yasir.
Probability of B2 given A.
What is the probability? It was B2, okay.
Yeah, given A.
Given A. This is required. And this is the simple application of conditional probability formula. There is nothing new in this question. You just open it as a formula. B given A will be probability of A intersection B2 divided by probability of A. And this denominator, it will come from the theorem of total probability. You just found it, 0.0086. About the numerator, again, this numerator can be opened in two ways, and both of them are correct. I'll say none of them is incorrect. This can be opened as probability of A into probability of B2 given A, and it can also be opened as B2 into probability of A given B2. Now, one of them is useful and one of them is inapplicable here. It's not wrong. It's you don't have information, enough information to use that method. And which one is not usable here? Abdul Aziz.
The left one.
The left one is not usable. I'm going to give it a red color. Why? Because in the left one, you need probability of B2 given A, which you are trying to find. So of course you don't have this. And the right one is the one you are going to open it like. So the numerator, you will open it like the right one I highlighted. So this one is equal to probability of B2 A given B2 divided by the probability of A. And this is going to be 0.3 into 0.01 over 0.0086. Which gives you the final answer to be equal to, what is the final answer? It is 0.349. So if you selected an object randomly and that object is defective, there is a 34.9% chance that it was manufactured in Riyadh. And the formula you just used in this question is called a Bayes formula. It's called Bayes theorem. So now I'm going to write the general format of theorem of total probability and Bayes theorem. The theorem of total probability can be written as probability of A is equal to probability of B1 into A given B1 plus probability of B2 into probability of A given B2 plus so on. It doesn't matter how many partitions of space do you have. Probability of BK into probability of A given BK. This is the general format where I have K partitions of my sample space. These K partitions can be 2 partitions, 3 partitions, 4, 5, 10, any number of partitions. So in a compact form, I can write it as summation I equals 1 to K probability of BI into probability of A given BI. This is called the theorem of total probability, where you are trying to find the total probability like CGPA. The weight of the credit, this is the credit of every course multiplied by the GPA of every course. Add it together. And similarly, probability of BI, any I, whether it's B1 or B2 given A, like we found B2 given A, this is equal to probability of BI into probability of A given BI divided by the total probability of A. This is called theorem of total probability. And this is called Bayes theorem. Any questions? Muhammad Faris, do you have a question?
Yes, please. All of the theorems are working, no condition, right?
What do you mean by working?
I mean, if I have like all like a probability of B or and BA given B or and probability of A, I can do it.
Yes, you can apply it everywhere
Mm.
where the scenario is like your sample space is partitioned into 2 or more than 2 pieces, and then in every pieces there is a specific event A where you are interested.
Yes, thank you.
It can be like this. Let me show you. It can be like this, a space where it's divided into 2 pieces and you're interested in this event A. It can be like this, where your sample space is divided into 3 pieces and you're interested in A. It can be like this, 4 pieces and you're interested in A, and so on, any number of pieces. K can be 2, 3, 4, 5, 6, any number of partitions.
Yes, can I do it like I have two criteria like 2 circles like at the beginning of the classes?
You can only apply it when your original event B1, B2, whether it's B1, B2 or B1, B2, B3, they should make the whole sample space.
Yes.
Otherwise, you cannot do it.
Okay, thank you.
Let us solve some of the questions from this problem to get used to of whole chapter. And I'm going to go quick on these problems because I want to start chapter 2 now, chapter 3. We're already behind, so I'll be quick. This question says that I'm going to highlight the important information. This question says that there is a factory where there are 2 machines installed for the production. There is machine A and there is machine B. A lot of production is inspected and it is found that 2/3 of the products are made by machine A. 2/3 of the products are made by machine A. This is one piece of information. It is also found that 3/5, 3/5 of the products are scratchless. That's another event, scratch or scratchless. Moreover, 5/8 of the products have scratches or they are made by machine B. I highlighted 3 pieces of information. And finally, what is required? The required thing is what is the probability that a product selected at random from this lot is made by machine A and it has a scratch. So let us go one by one. Let us try to write the events, and then I will ask you one by one what is the meaning of the green highlighted thing, what is the meaning of blue, and then what is the meaning of all the things. Let me write the events first. I have event that A product is made by machine A. And B, that product is made by machine B. S, that the product has scratch or scratches. With respect to these events, I want you to tell me what is this probability of 2/3. What is this 2/3? Raise your hand. Abdulaziz.
The products are made by machine A.
So what is this event?
A.
A. This is the probability of A. Let me highlight it back to the green color. Second, what is this 3/5? Probability of something equals 3/5. What is this? Raise your hand if you know it. Nawaf.
This is the probability of S complement.
This is the probability of S complement that it is scratchless. So let me say it is S complement. And you can also define the event S in the opposite way. You can define S as scratchless also, it doesn't matter. In that case, S complement will be that there are scratches. So we defined it in the other way. We defined S as a scratch and S complement as scratchless. Then the question says, moreover, 5/8 of the products, they have scratch or they are made by machine B. What is this? Ali.
It is the probability of S union B.
S union B, exactly. This is the probability of S scratch have scratch or union B. That is given as 5/8. Let me highlight it back to the same color that I gave it in the question. This is the given information in the question. Then the question says, what is the probability that a product selected at random from this lot is made by machine A and it has a scratch? What is required in the question? Ali.
The probability of S intersection B.
Probability of S intersection B or B intersection S, that is required. Very right. How do we proceed with this question? This is the most important part of any question. Number 1, defining the events. Number 2, extracting the information. Number 3, what is required. Once this is done, 80% of the question is done. Now there are some hands raised. I suppose there are some questions or maybe some answers. So I will start with Abdulaziz.
Yes, I have an answer.
Yes, go ahead with your answer.
I believe you can use the formula of the union, where we can say
we can use the formula of union. Yes, we can.
Yeah, the probability of S plus the probability of B minus the probability of intersection. Then we move it to the other side, and then we subtract, and we get the final answer.
Exactly what Abdulaziz is saying. We can use this formula. And again, I will reiterate the fact that using the formula and getting the answer is only 20% of the question. 80% of the question is what? Reading the question, extracting the information, and knowing what is required. The things I just highlighted, 4 of them, that's 80% of the question, along with defining the 3 events. So we write as probability of S union B equals probability of S plus probability of B minus probability of S intersection B. So from here we need S intersection B. S union B is given as 5/8. Probability of S is not given. Probability of B is not given. How do we fill this table? Where is probability of S? Who can tell me? Raise your hand. Muhammad Ali.
1 minus S prime, S bar.
1 minus S. So indirectly, let me pick this one and put it right here. And along with S bar or S complement, I can say probability of S will be 2/5. So I plug in 2/5 here. Plus, I don't have probability of B. Who can tell me what is probability of B? Ali,
1 minus probability of A.
1 minus probability of A. So here indirectly, I'm given that probability of B is 1/3. So there is 1/3. So you solve this equation from for S intersection B, and you get the final answer, which is 0.1083. So probability of S intersection B is 0.1083. Any question from this problem? Okay, we have another question here. Again, I'm going to start with highlighting the important information from the question. The question says that an aircraft emergency locator transmitter ELT is a device designed to transmit signals in case of a crash. The A manufacturing company produces 80% of the ELTs. The B manufacturing company produces 15% of them. And a C manufacturing company produces the remaining 5% of them. Then it says that the ELTs made by A company, they have 4% defects. Those made by B company, they have 6% defects. And those made by C company, they have 9% defects. If an ELT is randomly selected from the general population of all ELTs, find the probability that it has defect. So I'm going to write down the events. I'm going to write down B1 as the probability that ELT is made by A company. B2 that it is made by B company. B3 that it is made by C company. And I'm going to define A as an event that ELT is defective. Now I want you to tell me what is the given information. First, the green part. What is the green part? There is 80% chance that the product is manufactured by A manufacturing company. What is this? Nawaf.
Probability of B1.
Probability of B1 is 80%. Yasir, what is the probability 0.15?
It is the probability of Brian company makes 50% of them.
In terms of event?
B2.
B2. Muhammad Faris, what is 0.05?
Probability of B3.
B3. Naif, what is 0.04?
Can you go up, please, to read the question?
Yes. The ELTs made by A company have 4% defect rate. What is this 4%?
Probability of B1 and A.
Probability of B1 and A. Is it right?
No, doctor.
This is not right. Ali, what is the right thing? What is 0.04?
It is A given B1.
It is A given B1. It is the defect rate within company A. Similarly, the defect rate within company B is A given B2. That is 6%. And similarly, probability of A given B3 is 9%. Be careful when you are converting them into probabilities. You may write 4% as 0.4. So making this small mistake, you will not be able to reach the right answer. So the defect rate for each company is given, the weight of each company is given, and finally the question is, if there is an ELT selected randomly, find the probability that it is defective. What is required in the yellow color? Knife.
Probability of A.
The total probability of A. This is required. Very nice. This was blue color in your question. This was yellow color. This, then I used blue, this one for blue, and then I used this thing. No. I used this color, and then I used this color. Okay, so probability of A is required. So this is going to be simply what? The weight of every company multiplied by the defect rate of every company. 0.8 multiplied by 0.04. 0.15 multiplied by 0.06. 0.05 multiplied by 0.09. The only thing you need to be careful here is do not multiply the weight of one company with the defect rate of another company. Make sure that it's the same company you are multiplying the weights of. So the overall defect rate of ELTs is 0.0455. Look at the second part. The second part says if a randomly selected ELT is found to be defective, it is found to be defective, find the probability that it was made by company A. What is required? What is given? Now I'm going to write this one as something given something. Now who can tell me what will come here? Yasir.
B1 given A.
B1 given A. Muhammad Faris, is this right?
Yes.
Yes, this is right. So we are going to make a simple use of Bayes' theorem. This can be written as probability of B1 into probability of A given B1 over the total probability of A. And this will be 0.8 into 0.04 over 0.0455 that we just found. Therefore, the overall answer will be 0.703. So if you found an ELT to be defective, there is a 70.3% chance that it was manufactured by company A. Knife, please go ahead.
Doctor, in part A,
Mm-hmm.
how I know I use given role or and?
Again, look at the question. Look at the, I'm going to unhighlight all these things and I want you to look at only this blue part that I have highlighted. Now look at this blue part. The ELTs made by company A have a 4% defect rate. Now, does this sound like, is it probability of defective intersection B1 or is it sound like probability of defective given B1? When you're talking about 4%, what does this 4% sound like? Is it sounding like the intersection probability or conditional probability? This is basically a conditional probability. How do you know it? Because the question says the ELT is made by company A. So you know those made by company A, they have 4% defect rate.
Okay.
Got the point or no?
Yes, I got it.
Let us move on to the next question quickly. Again, we will read the question and try to highlight the important information. It says that the silicon wafers are used in manufacturing of integrated circuits. Of the wafers manufactured by a certain process, 10% have resistance below specification. I'm going to highlight this information. 10% they have resistance below. 5% they have resistance above the specification. So I'm going to define events, let us say A, that the resistance is below specification. And I'm going to define B as the resistance is above specification. Now the sum of these two is not 1. Who can tell me why the sum of these two is not 1? The probability of A is given to be 10% from the question. 0.1. The probability of B is given to be 0.05. And the sum of these two is not 1, it's only 0.15. So there are only 15% of the products that this is given in the question. Where are the remaining 85% projects? The products. Amjad.
Because they are below and above, there is the middle.
There is a middle part which satisfy the specification. So those 85% of the products are satisfying the specifications. So they are according to they meet the specification. So if you talk about all three categories, that should make it a whole 100%. So obviously from this information, you can say if the question says what is the probability that our product will meet the specification, that's 85%. Simply. So let us say what is the question. Find the probability. I will highlight it in the yellow color, that the resistance of a randomly chosen wafer does not meet the specification. Does not meet the specification. What does this mean? It does not meet the specification. Does not meet the specification means that, yes, Ali.
It says that either above or below the specification.
Either above or below. This is what the yellow thing means. Very nice, Ali. Who can tell me how do you find this probability, Nawaf?
Probability of A union B.
Union B. Very nice, Nawaf. Ali, how do you open probability of A union B?
It is probability of A plus probability of B minus probability of A intersection B.
Very nice, Ali. Who can tell me what is probability of A, what is probability of B, and what is probability of A intersection B other than Nawaf and Ali? Amjad.
Probability of A is 0.1.
0.1.
B 0.05.
0.05.
And B 0.
Why it is 0?
Because they have no connection between each other.
And from where did you get this information that there is no connection? This is important. How do you extract from the question that this probability is 0?
I don't know.
Okay, Abdulaziz.
Because it says like 10% are below and 5 are above, so they have nothing in common.
They have nothing in common. It is like, for example, you're trying to see the length of tube rods. This is the length of tube rods. If the tube rods are around 1 meter, that they will fit nicely in the space where you want to fit the tube rods. If it says that if they are below 0.99, they will be too small, they will fall. And if they are above 1.01, they will not fit into the space. The tube rod will be too big to fit into the space. Now imagine below 0.99 is like below specification. Above 1.01 is like above specification, and within these two is like they are meeting the specification. Now imagine a tube rod. Can there be a tube rod which is below 0.99 and at the same time it is above 1.01 in length?
No.
Of course, no. These two events are mutually exclusive, as Nawaf said. So they cannot occur together. You cannot have a product that is below specification and at the same time it is above specification. Each product will belong to either of the 3 categories. Either it will be below specification, or it will be meeting specification, or it will be above specification. So the intersection probability here, as all of you said, it is 0. So let us talk about the second part. If a randomly chosen wafer has a resistance that does not meet the specification. I'm going to highlight it with this blue color. This is given information. What is the probability that it is too low? Too low means below specification. So what is required in this question? And what is given in this question? Muhammad Faris.
Sorry, doctor, I forgot to down my hand.
Below specification. Given does not meet specification. This is the question. That means this is required. And this is given, does not meet specification. Who can tell me what is this probability in terms of the events we just defined? Saud.
I believe it's 0.1 over 0.15.
No, don't talk about the answer. What is this yellow thing below specification in terms of event? What event is it?
It's below specification, which is, I believe, can I see this question?
Yes, I just scrolled up. Look at the top of the screen. What is the notation of this event?
A.
A.
Which is B of A, yes.
A. Given. What is the blue thing? Does not meet specification.
The whole thing. A and plus B.
A
which
plus
is A.
Use the notation,
A,
proper notation. A
and B.
A
right?
and B. A intersection B. Ali. Ali Abdul Rauf.
A union B.
Not meet the specification. Is it A intersection B?
No, A union B.
A union B. We have another opinion. Abdul Aziz.
Yes.
Does not meet the specification. Is it union or intersection?
Union.
Union. Jafar.
I agree with him. Union.
Union. So it is yes, it is union, because does not meet specification either low or high. In both cases, it means it does not meet specification. So it is A union B. This is what is required. So apply the simple conditional probability formula. You get what? You get probability of A intersection A union B divided by probability of A union B. Now I'm going to explain something to you, that what is A intersection A union B through a diagram. This is space, this is A, and this is B. According to this question, this is the diagram. That's not the general diagram. I kept them mutually exclusive because in the question they are mutually exclusive. This is your A, this is your B. Now I'm going to highlight A with the blue color, also B with the blue color, and the whole blue color is A union B. The whole blue color is A union B. Now who can tell me what is common between this blue color and A itself? This is A, this is B, and the whole blue color is A union B. Now who can tell me what is intersection between the blue color, which is A union B, and only A?
A.
It's A itself. And I repeat, this is not a general rule. This is only according to this question's information. This is not a general rule. In general, A intersection A union B is not equal to A. This is only because of this question that they are mutually exclusive. In that case, yes, they are. So you have all the tools to put them. A is given as 0.1 and A union B is given as 0.15 from part A. So you get the final answer. 0.66. So I would like to stop here. we will complete the remaining questions in the next class, and we will start the third chapter in the next class. And from the next class, I'm gradually going to pick up some pace. So before the next class, I want you to come prepared with at least watching the recordings of the lecture, so that I don't have to refer back for everything to the previous chapter. I can go quick. If you have any questions from today's lecture, you're most welcome to go ahead. Otherwise, you may leave the session at this point. Muhammad Faris.
Yes, doctor. In the first part, A. Like, why we don't say like does not meet the specification 1 minus 0.06?
Does not meet the specification 1 minus 0.06. Where is 0.06?
No, I mean 1 minus brackets 0 1 plus 0.06.